what I will talk about is the following. So first of all, yes, I will introduce Abby, what we are doing as a company. I have to give you a very short overview that you understand the scope of our products. And I will tell you something about how Abby technology was used a little bit in the impact project. Then we go to the technical area. This lists some optimization we have done throughout the whole project. And at the end, I will sell something what we learned in impact and also what something to announce. But this is the surprise for the end. Okay, first Abby and impact. I'm not sure. Yeah, you can see it on the board. First of all, Abby is an international company. We are around 1,000 people, employees worldwide. The headquarter and all the R&D development is done in Russia. So headquarter is in Moscow. I'm from Abby Europe. We are responsible as a sales and marketing and technical organization, sales support organization for the Western European countries. We have also colleagues in the US. We have a local office here in the UK, Abby Australia, Abby Japan. So there are different Abby subsidiaries all over the world. My position as a product marketing manager, I'm sitting in between all chairs. That means on the one hand, I've got the sales teams, I have got the customers. On the other side, I have the developers that did all the work for impact in Russia. And when they heard that we are allowed to present the results, they said, oh no, that's your job. So they did a very good job, but they are not keen on going to public and present that stuff. About the product overview we actually have. So this is just a subset of the technologies Abby offers. So Abby has a very big linguistic branch, which I'm not talking about here. You probably all have heard the word FineReader a lot of times, and you can see FineReader is listed here, and it's listed under desktop and workgroup tools. It is a desktop application, it's user-driven, so the user can scan or open a page, open an image PDF, can apply OCR and can export it. That's fine, end user use it, companies use that, and also libraries, we've learned use that a lot. But it's important that this desktop product is not able to process old fonts. It's just not in the product. Then we have a second range of products, which we server-based processing. Here the focus is on automated processing. So you can feed masses of images to that server system. It is scalable. It has a similar architecture we have seen before, so manager and multiple processing station. It can be scaled up. It can be fed via hot folder, via API, via email, via a scanning station, and all these kind of things. It supports historic OCR, and it also has XML output. Here, the focus is companies, scan service providers, or libraries, of course. And last but not least, we have our technologies in form of an SDK, and it's called the FineReader engine. So every time in this environment, when somebody says FineReader, please think of the SDK and not of the desktop product. That's very important. These technologies are available for Windows. This is the main platform, but we also support Linux. We support macOS, FreeBSD. We have versions that run on embedded systems. Also, the SDK technology is available on mobile phones already. So tools like Business Card Reader you might have heard of. So keep this please in mind. As Günther said, Abby was invited to work in the Impact project a few years ago. And Abby was chosen as the core technology provider. But it's not that we only provide the licenses for the Impact projects, we also are part of the improvement process. So we have improved our technology in different areas, and I will cover this later on in more detail. The second, I mentioned already, it's the SDK that was used, not the desktop application. The reason for that was Impact is a research project, and to do research you have to have a sophisticated API, you have to run tests, you have to do this multiple times, you have to have low-level access to the technologies, and this is not able with a closed desktop application. And the good news is for our customers is all the technologies Abby developed during the Impact project is going back into our products. And this also was mentioned a little bit. A lot of the tools are in a development stage, and for ABI the challenge is always to productize these technologies so that they do not disturb the rest of our technologies we have. So they have to make the overall system better, and not only on old fonts or not only on invoices. So this is what we try to do, and this makes it a challenge to productize the stuff. So now I would change your mindset a little bit, and I would like to talk about captures. Every one of you has seen these captures on the web, and you can see some gaps here, and I thought I can fill them up with images from Impact. So I'm pretty sure most of the end users in the web do not see a big difference, but there is a big difference. Captures are designed to be not OCR'd, and here the project of Impact is to read this stuff. So you can see we're not talking about normal OCR, because when we talk about normal OCR, and we apply normal OCR technologies on Fraktur texts, we just get garbage. It's absolutely not usable. But if you use the correct OCR system, you can get pretty good results. Okay, in this image here is really perfect, but nevertheless it works. How does this come? The history of ABI and historic font OCR is now over 10 years old. It was mentioned from Klaus Grafenhorst that during the Meta-E project, ABI was also a partner. Started in 2000 and ended in 2003. And during these 4 years, ABI developed this Fraktur Gothic OCR. And it was rolled out in a desktop version called FineReader 19, or XIX, how it's called. This product now is buried. It's end of life because it's just not good enough anymore, and we will see this later on. Then the technology was continuously improved in our SDKs, in our technologies, and when Impact started in 2008, it was the release 1 was at that time defined as state-of-the-art technology, and the good thing was exactly to that time, when Impact started, we started the planning for a new technology cycle. This was technology cycle 10. So we always had the Impact improvements in mind when we developed FineReader Engine 10. The achievements, could be a summary slide, and Hinderlis already showed that. So overall, compared to the technologies from 2007, we made an improvement of almost 40%. Less errors, and even to the state of the art, it was around 25%. And of course, you will see this later on, a big difference how good the images are in terms of quality. We've heard it several times, good images deliver much better results. And if we have really good images, the achievable OCR quality is almost 98%. 2%, but this is on a character level. So I'm talking, when we talk about qualities, about character level, because this is what the OCR companies are used to. We try to change our mindset for the future to get more on the word level. We learned that from Impact, but technologies are available and it's possible to get good results. So on this slide, I can save a minute because I think I do not have to explain the different processing steps in OCR. It's just, I will walk you through the different improvement areas that actually then, and show you some images mostly to explain you where we made improvements and optimizations. First of all, I would like, as everybody here, talk about image preprocessing. When an OCR company talks about image preprocessing, they have one goal in mind. They want to separate the text from the background. The background could be gray, could be color, could be even an image in modern magazines. At the end, we've also learned that the OCR is applied on a binary image. So it is very important how you get to this binary image. If you have critical document, as you can see on the bottom left side, it goes from black to gray and from gray to white. And if you apply a simple binarization algorithm, like threshold of 50%, you lose 50% of the document. That's clear, it's not acceptable, but it's also what Apostolos showed when you use simple binarization algorithms from scanners. It's just not good enough for our purpose. Why is it so critical? Because it has a strong impact on how the characters look like. So in the middle, the welcome is easy to read for a human and also maybe readable for OCR. but if you go down, the characters fall apart, and if you go up, the characters glue together. They get too fat. So they're not separated, and the more to the extremes, the harder it is to read. So this is really something you have to have in mind. So we have a sample scan that has exactly this problem. If we binarize this scan with version 9 technologies, you can see that on the left part, where the gray of the character and the gray of the background are very similar, we lose some text. And that's actually not actually what we want. So improving binarization means actually losing less text on the image. And I think this and the next image shows also that feeding the OCR with a more or less good quality medium sized or image with grayscale, there's more digital meat on the bone. So the algorithms can do something with that. And here the result in Engine 10 sees that even in this low contrast scenario, the text can be kept. Now you can say, what has this to do with impact? This is on the next slide. Here you have a grayscale image that has shine through from the other side. So in this area here. And if you binarize that, even with our technologies, you have some 2 ghost lines. Programmers know garbage in, garbage out. The OCR, of course, tries to read that, and of course it will fail because it's not there. So the new binarization approach we have done is to detect these kind of artifacts and try to get rid of them. And if they're not there, they cannot generate any noise during the OCR process. So this is why binarization is important, and I think this is the answer why we as a technology provider would like to see minimum grayscale images. Color is nice to have, but not the core recognition doesn't not in the current technologies take too much advantage of that. You get the color information in the output, that's okay, but for the recognition process you need a good quality binary image. Okay, the next step, we said now we assume we have a nice clean image. It was straightened, dewarped and everything. Of course, our SDK can also do these kind of things. Then you have to analyze the document. We have seen that as well. You have a pixel cloud and you have to find what is text, what is an image, what is a table, in modern document, what is a barcode, and you have to reconstruct that. And at the end, you break it down to the character level. But first of all, it's defining the areas of interest. And overall, of course, our technology works rather good. I think everybody has seen our outputs of our technologies. But during impact, there was one critical area that it has a high relevance, and this is old newspapers. You know, old newspapers, dewarped, bad image quality, bad printing quality, but also very narrow columns. And now you will see 3 different types of errors we try to fix. And as you can see, these red areas on the left side, our algorithms decided this is probably an image. And this is also what Stefan mentioned, is when something is wrongly detected and it thinks it's an image, yeah, it's not sent to OCR. So on the right side in version 10 technologies, you see it actually got it right and put everything in one text column. In the second example, it found all text areas, but it has to do with the word order detection or with the reading order. So at the bottom, it was a little bit confused, and it tried, or it put the different areas into different text blocks. And yeah, of course, it would be OCR'd, but the reading order would not be correct. So you will not see that this is a line of numbers separated by a dash, for example. So this was something we fixed or we worked on. And the third problematic area is lost text. So in the bottom image, you can see that only 2 characters from the Africa headline were detected as characters. The rest was just skipped. And also, by correcting these kind of things, the whole text will be captured. How does this come, or what is the reason? Before we started with impact, or the overall approach to make our products better is a multiple approach from multiple frontiers. So overall segmentation is continuously improved in our product. This is why it changes from version to version, and it can happen that finally version 8 it processes a document layout different than the latest technologies. especially in the field of old newspapers. Yes, we had old newspapers and we worked with them, but it was a kind of random set. Now for impact, there was this ground truth material available, and we worked on a special, what we call internally, a document analysis model for historic newspapers. So imagine our algorithms see a document and they try to make the best guess. Is it a letter? Is it a magazine layout with background images? Or is it an old newspaper? And when it thinks it has multiple columns, it falls back into this special old newspaper document analysis mode, and then it can actually apply the logic for old newspapers. And overall, we used new approaches to solve these problems, and this turned out to be around 40% less errors in terms of split and merge errors, and 25% less lost text. Now we come to we have a nice image, we found the text blocks, and now we want to read that. This is just a slide from our regular presentations, and it just shows that EBI technology uses different classifiers to read the characters. And applying this or having this in mind, so we take the pixels, we have outlines, we have a kind of vector stuff, we have experts that can differentiate different characters, and we all have these things in technologies and they're used internally. So for impact, we improved these Gothic classifiers also based on the selected material that we got from the libraries. And this is important because the libraries made the selection and they said, okay, these are documents of historical relevance. And this is what we then put in. Also, we trained our toolkit new graphemes because we figured out that there are characters which are not in our OCR technology, but they even might not be in the Unicode output. So just by adding these kind of characters gives you a better result at the end. Here's the overall rating. So we did the ground truth testing, and we realized that around 2.8% errors on good quality images are possible, and on bad quality images it can be up to 7%, but it could be even, of course, worse. So there's no limit going down. Technologies are available in the SDKs already and in Recognition Server 3. Impact was expanded to the Eastern European countries during the project, and a new font or language popped up. It's Old Slavonic. So for me, it's a little mixture of old fonts and somehow Cyrillic, but our normal Cyrillic OCR was not able to process that, so we completely added a new classifier set for these languages. Okay, how do we test that? So is it only the binarization? Is it only the recognition? So what we did is we took a test set and binarized this with version 9. And then we recognized this with version 9 technology. And the output we got, we defined as the text, and we knew how many errors there were in. Then we applied version 10 recognition technologies, and we saw, oh wow, we get 5% less errors. In the next step, we binarized the whole set of documents with version 10 binarization and read or applied the version 9 classifiers on that, and we said, oh, it's 11% less errors. And if everything goes wrong, or no, the everything is right, it didn't go wrong, version 10 binarization and version 10 classifiers reduced the amount of errors for around 15%. So this shows that there's no single button you can press to get the best quality. You have to do a lot of testing. Just one slide on other improvements. The dictionary API was mentioned by Klaus Graufenhorst, and the language partners use this API a lot. It's, for you who do not know, it's well documented in the API, and this intense testing actually made the API better, and we improved things and added some things when issues came up. And we also added the Alto XML format next to the normal EBI XML output to Fine Reader Engine and also Recognition Server. So it's just now an option you can export. Some additional notes. We relaunched an old web page. It's frakturschrift.com and frakturschrift.de. It's in German and in English, and this is a kind of microsite where you can find case studies, where you can request a recognition server trial, where we put some general information on that, which is not so relevant for abby.com, but here we have good flexibility and we assembled a lot of material there already. Also, Abby learned something from the impact project. What did we learn? So we talked a lot to libraries and to the institutes that were in there, and we learned that a lot of books are available. So not individual items are counted, it's meters of shelf space. And even the stuff is starting to be scanned, but it's unclear if the documents have only Antiqua fonts or modern fonts or also historic fonts. And we also learned that pre-sorting the materials is just not possible just because of costs and time. Everybody of you, I guess, has a digital camera, and how hard it is just to delete old images you do not want to have. So what do? You just keep them because storage is so cheap. And this is the same problem. To save costs just on clicking through 10,000 images is not really a good thing. So this is like the Gordian problem Alexander solved. So we also tried to solve that. And what we did is we dramatically reduced our pricing for these mixed font type scenarios. So our long-term goal is actually that it costs a little bit more than normal OCR, but you should be able to use it now. Here are just some examples. The cheapest entry point is around 150 euros for 2,500 pages. For 10,000 euros, we will charge you 300 euros. You can buy the license online. Even 500,000 pages, also 500,000, is around 5,000 euros. And this is actually 1 euro cent per page. At the beginning, we started at 8 cents per page, but we reduced it dramatically. So applying this on a book with 250 pages would mean you could OCR around 2,000 books. Even if you have to do a second or a third run with different settings, it should not make you generate this high amount of costs. Even if you go up to 3 million pages, it is under 1 euro cent per page. So a book would cost you 1.25 euro. We think that's okay. And it goes down to around 10 million pages, so the OCR costs for one book should be around 50 cents. So I think there's nothing to complain, because probably only the costs for getting the book from the shelves would probably cost you 50 cents. So even if you have that stuff, the materials here, we said, now there's no excuses from your side. Tell me if I'm wrong. Okay, here, short pre-announcement. I told you you have access to the technologies via the SDK and via recognition server, and to normal font OCR also via the desktop application. What Abby will do is we have already an online service that can be used via the browser, so you can upload a document and you get the results back. Only last week my colleagues enabled Fraktur for that. But it's not ready yet. It's not fully rolled out. So German and I think Latvian is available. Other languages might follow. And also probably uploading 1,000 images via browser is not what you want to do. So there will be a second flavor of OCR, and we call it the Online OCR Sdk. So it will be a service running on Windows Azure. It will have a full API so that you can feed the service. You can set up the languages, and you can get the information back in XML, in searchable PDF, in text only. Current status is we're in closed beta testing. So if you would like to test the service, currently it's about API testing, you can contact me and you might test that. And we plan to go into public beta in Q1 next year. So then the service is probably not fully scaled, but the API and also the login stuff is available online. So this is just something that we're rolling out OCR in a new flavor. And especially for libraries, we think it's interesting because your content is normally not really risky or high security things. It's out of copyright, so it might be a good thing without installing software on your own side. Pricing is not defined yet. Summary, I also went into history, and I thought I'd take a Greek guy. And we think, or all the approaches in impact show that the whole is greater than the sum of its part. And this is especially true when you try to get good quality results on historic material. So it's not just one button, as I said, it's really multiple areas where we have to improve and to work together. Good. Thank you for your attention. So we are right in the middle of our break, but maybe there are some questions. Even not now, I will be here or in the evening.
In one of the first sessions we heard that the best OCR quality was with, if the DPI went up to like to 500, the OCR quality didn't improve. Is that something that you acknowledge?
Yeah, I forgot to mention that. I planned to set that when I showed you the classifiers. Yes, our technology is actually improved for 300 DPI. Our recommendation is 300 DPI for fonts sizes down to 9 to 8 point. So it works rather good until then, because if you have smaller characters than that, you probably should go up to 400 if you have 6 point dot fonts. But if you feed the OCR engine with too much data, there are too many pixels. So the pixel or the character pixels are too big. So they are out of the scope of processing. Yes, 300 DPI is also, you can run into these problems if you have old newspapers with very big headlines. The technology might not detect the headlines because they are too big, because they are out of scope. On the other hand, if we have very low resolution documents like Fuchses or other stuff, there's a special mode in FineReader Engine for these low quality images. There we use a different set of classifiers.